Okay,
I'll let you do your thing.
right. Yep. Hello, everyone. Can everyone hear me? All right. Welcome to the first AI/ML Loft event of 2020. My name is Morrison. I am a principal solutions architect focusing in AI/ML. I focus mainly on media accounts, but I focus across the broad portfolio of AI/ML services. So this is the beginning of a multi-day effort to help you understand AI/ML and where it positions itself in the AWS stack. So the goal of AWS is to put machine learning in the hands of all developers. And we'll talk about all the different ways we go about trying to do that. Our intent is to make it easier to build. Easier to build, easier to deploy, easier to run in production, and easier to scale and easier to apply what you're doing in ML to your business. Let's start with, has anyone been to a Loft event about AI/ML before? Is this a first event for most people? Okay. I'm going to talk about the machine learning stack. First, I'm going to show you the stack as it stood last year, which is a lot of different services across a lot of different technology levels, from developer to data scientist. Moving into this year, the ML stack has grown significantly, and I'm going to focus a lot of today on where we've improved, where we've enhanced the service. A lot of the different workshops throughout the week are going to cover different services within this stack. Some of these things are so new that they're in preview, and we may not get to in the short amount of time we have, so that's where I encourage you to keep checking with the Loft. We run these very, very frequently, and the agenda changes throughout the different times we run it. So the stack as it is. We start at the bottom with frameworks and infrastructure, and this is where developers and data scientists, heavy data scientists, will end up working. So this is the frameworks, the actual hardware that does the training, and moving up, we have ML services, which are more data science and developer focused. So that is the end-to-end training workflow. And at the very top, we have AI services. These are API-driven services where you feed it data. Could be an image, could be text, could be view data from an application, a streaming media application, could be financial data for fraud detection. And we will either give you an inference based on a model or train a model on your behalf and give you an inference based on that. So again, bottom of the stack is developer data scientist. We'll go into each of these a little bit. Unfortunately, we have so many services. In the 30 minutes I have to kick this off, I can't even explain what each service does in due course. So at the bottom, we have our frameworks. So we are framework agnostic. Our goal is to give you whatever tool you need to do your job. So that could be TensorFlow, PyTorch, Chainer, could be one that hasn't come out yet. The AI space moves very quick. It's moving multiple times the speed of Moore's law currently. So our goal is to be able to get you compiled, optimized versions of these frameworks as quick as possible. And you can run them fully managed or run them yourself on EC2 using the GPU-backed instances if needed. So we have optimized TensorFlow to run in AWS. So that's making it more efficient at scaling, running distributed with tools like Horovod. And it is also available in both SageMaker and the deep learning AMIs as well. And the deep learning AMIs is the Amazon Machine Image. That's again at the bottom of the stack, where it is a pre-compiled with the frameworks, with optimized for CUDA drivers and all the things that generally make it hard to build an instance. So the deep learning AMI comes with the frameworks you see here. We also have a deep learning container, which is built for both EKS, so the Managed Kubernetes Service, and ECS, which is our Elastic Container Service, optimized for TensorFlow and MXNet. So what we'll be talking about a lot over the next 2 days is the difficulty in building, training, and hosting a model. We like to think it goes like this, but in reality it looks more like this, with a lot of work in data prep, a lot of work in training, choosing a model, optimizing that model, and then where a lot of people haven't even focused a lot of time in is actually once you have that model trained, you've got good results, how do you host it for inference? You know, a small application inferring a couple times a second is one thing, but a large-scale application that looks for millions of inferences is a totally different thing. So moving up the stack, that's exactly why we developed SageMaker, which is to take this and make it easier, make it something that you can do in an automated, productionized methodology. So SageMaker is a suite of services that starts at the very left with unlabeled data and then moves all the way through building, training, and hosting a model. It's also worth noting we have third-party models that you can actually just build and implement in SageMaker as well. So if you have a model or if there's a partner that has a model that is beneficial to you, you can actually just one-click deploy it in SageMaker. If you actually are building models, you can actually host and sell your model through the AWS model marketplace. Finally, after the model is built, we have SageMaker Neo, which helps in compiling that model for distributing it in multiple locations. So we're going to go through some of the recent updates here that we've launched in the last year. Over the last year, we've had 50 new capabilities launched for SageMaker specifically. As I showed you in the windy line, the machine learning workflow is iterative and it's complex. So the first step is preparing your data, which is collect and prepare training data of all forms. Once you have that training data, you need to choose or build an ML algorithm. So depending on what you're looking to do, be it linear regression classification, any different type of decision trees, you need to choose an algorithm. Then you need to set up and manage those environments for training. Training may or may not go very well depending. You might run into issues. Your data may not be completely ready for the training. You need to train, debug, and tune those models. Then you need to manage the training. So once you have that, you need to deploy the model into production, monitor its accuracy, validate that it's still accurate, and potentially retrain that model to keep up with your incoming data. You also need to scale and manage the production environment for that model. So where SageMaker fits in. We've recently launched a web-based IDE for machine learning. We've added a lot of features on the left. We'll go through many of these one by one, but we have fully managed data processing jobs and data labeling workflows. We'll get into each of these different service enhancements in some detail. So when it comes to the integrated development environment, we launched SageMaker Studio, which helps with collaboration at scale, allowing you to share notebooks. We'll talk about the experiment management, allows you to do automatic model generation. This is the suite that contains a lot of the different service enhancements. So here's what it looks like. It is a single pane of glass that allows you to create and review your models. Oh wait, sorry, wrong slide. I don't have another slide on Studio. So Studio, as you see, the automatic model generation, which is SageMaker Autopilot. Sorry, I had a screenshot of SageMaker Studio. I can pull it up later. But SageMaker Autopilot allows you to create and review specifically right now classification and regression models. So it allows you to automatically choose, and you can specify a performance metric that you're looking for, so the objective here, and allows you to run multiple training jobs, really take your data, process it, and featureize it, and then build a model towards your accuracy requirements. On top of that, the concept of managing your experiments. So we've also launched SageMaker experiments, which allow you to track your experiments at scale. So you can track your parameters, your metrics, you can organize them, you can visualize the results of those experiments. Helps you to iterate fast through different experiments. These are all live in the console today. Some of these, again, are in preview. So there is preview documentation on how to access it. The next challenge people had is sharing, collaborating when it comes to data science and reproducibility. So this is an area where large, complex, multi-stage pipelines, custom code dependencies, all make it significant work to reproduce an experiment. SageMaker Notebooks allows you to build and collaborate. And again, this is one of the preview services. So it allows you to log in with SSO. They're fully managed and secure. They're very fast to set up. You can spin up your notebooks without necessarily spinning up all the underlying compute resources. It allows you to share notebooks with a single click. And not in the preview yet is the ability to spin up and down the compute resources as needed. So this is collaborative notebooks in SageMaker. Within SageMaker, and this is not a comprehensive list, we have a lot of built-in algorithms. This number is growing constantly, but these are designed to help you build a model for specific use cases, XGBoost, linear learner, image classification. We don't have reinforcement learnings in here, sequence to sequence, like depending. Each of these has been built and optimized, and many of these are also optimized to run distributed. If possible, the algorithms have been built to run on multiple different GPUs when training. So you can effectively train faster at the same cost using many of these algorithms. Next problem people run into is debugging and profiling deep learning is painful. With neural networks, you have many layers, many connections. It's extremely difficult to debug and profile what is the black box of a neural network. So with that, we launched SageMaker Debugger, which allows you to capture the relevant data, debug your models, analyze and debug the data with no code changes, look for errors automatically based on specific rules, take corrective action, and also visually analyze the model that you've built. So again, this is all available from SageMaker Studio. The next challenge is ML requires complex, hard to discover combinations. So again, requires broad knowledge of ML data, algorithms. So this is where, again, unfortunately the slides showed up earlier, but SageMaker Autopilot, which is the ability to automatically create a model and tune that model without necessarily needing to know all of the data science underlying details. So it allows you to provide your data in a specific format. It's bent specifically towards tabular data, so databases and spreadsheet type data. So it allows you to automatically create, again, classification and regression are the current features. It will generate notebooks for your models with the code, and it will also create a leaderboard and provide recommendations and optimization choices for your model that was created. This is actually in SageMaker Studio, and it is available. It's not in preview. So again, been through these slides. So the last problem is, now that you've got your models built, how do you make sure they're continuously accurate and continuously relevant? So the confidence varies based on input data. Not all predictions are equal. Your data changes over time. If you're modeling financial data, all new data, subscriber, user base, all new data that comes in changes the efficacy of the model. So you can't statically train a model. You need to continuously monitor that model and retrain it. One of the areas for confidence reviewing that we launched a service is Amazon Augmented AI. So it allows you to build workflows required for human review of predictions. So is anyone familiar with the phrase human in the loop? So human in the loop is an area of machine learning where ML is augmented or assisted by human activity. We actually started this journey with Amazon SageMaker Ground Truth, which is a labeling service. Again, I'm focusing on the new launches. I believe we'll cover the other Ground Truth at a different point. But it is the ability to pass activities to humans quickly to validate. So what autopilot or what augmented AI does, it allows you to take a result, and its native integration is recognition, text extract, and SageMaker, but it is an open service with custom capabilities. You can actually write a script to validate any type of response. So if you think about how it works, is you get a result. Let me make sure, see if I have a slide detailing how. So I don't have a slide to detail how, but a result comes in. So we'll say a computer vision result. You get the labels in that image, and you get associated confidence scores with that. Those confidence scores could range from 20% confident to 99% confident. Obviously, all ML is based on confidence scores for predictions. The 99% confidence score is likely pretty accurate. However, the 20% confidence score may not be accurate. So what AI or augmented AI does, it allows you to pass specific sets of rules to human workers. Those workers can be public workforces, such as Amazon Mechanical Turk. So that is the Amazon Mechanical Turk workforce, which is third-party, which is a group of people that work jobs on Mechanical Turk. So you can actually feed that out and say, I will pay X cents per image. And again, it doesn't have to be image, it can be text, can be any type of prediction that your model is making. You can pass that to a human workforce to review, and then that data can go back into your training environment, and it can also be used to validate that label, for instance. A2I and human in the loop in general is very important when absolute accuracy is important. If your model is not able to guarantee 100% accuracy, which models are not able to guarantee 100% accuracy, and you need that, you can pass it automatically to a human workforce. The next area is how to model and monitor the models. So this is the capability of monitoring your models over time to detect drift. So that is the ability to look at your data collected from your endpoints, define a monitoring schedule, detect changes against a predefined baseline. You can detect drift or write your own rules for custom analysis. The drift detection is built in, and it'll allow you to see your data statistics in SageMaker Studio. So you can then decide whether to automatically retrain your model based on new incoming data or whatnot. So that's the enhancements in SageMaker. The top of the stack, as I said earlier, is where developers generally focus, especially if they're not building and training models. So the top of the stack is API-driven services that you provide a specific set of data, and it provides that prediction. I'll go left to right really quickly. Recognition is our computer vision API, so it allows you to feed it an image or a video, and it will detect who's in that video, what objects are in that video, anything from content moderation, so looking for potential nudity or violence. It's great for media analysis. It's good for social media. Moving over to our speech services, Poly, which is our text-to-speech. So that uses neural TTS, or neural text-to-speech, to create lifelike audio from text. And we launched, late last year, we launched the capability for different emotive styles of speech. So a new announcement there was a newscaster. So Poly can now read in the cadence of a newscaster. Transcribe is our speech to text. So that is the ability to take what's being said in a clip, audio clip, video clip, and transcribe that down to text. So as I said, you feed it the image, the audio, or the text, and we'll go through each of these, and you get back a response. For transcribe, you get back a JSON of what's being said. For Poly, you get back a WAV file or an audio that can be played in concert with a clip for anything from dubbing or whatnot. And a launch we added for transcribe is we actually launched a medical-specific transcribe feature. So now, similar to what I'll talk about in a sec with comprehend, you can actually use it on medical dictation. Comprehend. That is our neural topic modeling and entity extraction service. So you feed it a body of text and it will extract entities. They could be custom entities. They could be dates, places. Am I talking about Amazon, the company, or Amazon, the rainforest? Comprehend allows you to feed it bodies of text and extract entities. The one area where you can actually train a model on your behalf is the custom entities and custom classifications. So if you feed it documents, you can actually train a classifier which will be trained in your account on your behalf. Amazon Translate is our neural machine translation service, which allows you to take pairs of languages. I believe we're up to 2,490 pairs of languages, or combinations of languages, 58 pairs of languages. Textract is our document analysis service. So that is an ML-based service that will take documents, extract data from those documents, forms. It's not just OCR, so to speak. It will take images, take documents, and it will extract the relevant data from those documents. Kendra is a new announcement, which is an ML natural language search tool that we announced at reInvent that allows you to take a data set, could be static and S3, could be databases, and allows you to do natural language search on that data. Lex is our chatbot service, which allows you to build slot intent-based dialogue chat sessions. So anything from, think of like an Alexa skill to a web chat for ordering or a web interface. Personalization, which is an area near and dear to my heart, is the area of recommendation and personalization, which is a very, very deep area. We actually have a session on it this week, so I won't go too far into it, but we've launched a service based on 20 years of Amazon's experience building and creating recommendation engines. Anything from the videos you see in the homepage of Amazon Video to the order of the art, a lot of different areas for recommendation personalization, search personalization, item similarities. This is a service that will build and train different models for different recommendation engine scenarios. Similarly, we've done the same with forecasting, which is 20 years of Amazon's demand forecasting and forecasting capabilities built into a service where you feed it data based on your time series data, and it can build and train a forecasting model in your account on your behalf. A new launch at reInvent was Amazon Fraud Detector, which is similar but for fraud analysis, anomaly detection, and looking for the possibilities of different areas of fraud. So that is a hosted service where you feed it data and will build and train a model on your behalf. Code Guru, which I think is particularly interesting to the people here, is a static code analysis or code analysis tool using ML to look for code issues. Finally, we also enhanced Amazon Connect, which is our contact center as a service. We enhanced that with Contact Lens, which is an ML-based contact center analysis tool. As I said, it's a lot in a very small amount of time. Hopefully, we'll be able to get into each of these more throughout the week. A particular cool addition we added to recognition at reInvent is the ability to do custom labels. If anyone has worked with recognition, we will work with recognition at the end of the day today. It allows you to detect labels. But working with a lot of media customers, every time someone wants X label, recognition has thousands and thousands and thousands of labels, but it does not have every label that our customers want, and we know that. So what we've added is we've added the ability to add custom labels, where you can actually upload images and use A to I or use ground truth to label those images, or have them labeled yourself, either or, and it will train recognition to recognize your custom labels now. So logo detection is a common use case. We're actually going to do logo detection later today, not with custom labels, but with SageMaker. Custom labels will make this even easier. So you can upload a handful of images of the label you're looking for, train a model in recognition on your behalf, and then evaluate if it's functional, if it's detecting what you're looking for. Here you'll see recognition, for instance, gives you plant, corn, food, vegetable. These are the recognition labels, but maybe you need to know whether it's sweet corn or field corn. That's a custom label job. So anywhere you need to really specify and really get deep into your individual use case, custom labels is a new option to help there. So Kendra, we talked about at a high level, but that is the natural language search engine. So it allows you, again, frequently what people end up doing when it comes to searches is anyone who has an internal search tool at a company has learned the weird code words they need to type to get the thing they're looking for. The goal of Kendra is to eliminate that, is to let people search in natural language. It's to let people say, where is the bathroom on the 6th floor? Not bathroom building type this and that type of thing. So it allows you to use natural language. It's ML optimized indexing, simple API. It is in the console today to get in there and start playing with. Fraud detector, as I talked about, these are a bit deep on the actual services. Allows you to automatically create custom fraud detection models. And it is, again, based on our own experience. It is integrated with SageMaker and allows you to review your detection logic. So with that, we also have over 400 courses to help people learn machine learning. So today is one of the areas, but we have a lot of online information as well. So Machine Learning University, it's the same data that we use internally to train our developers on ML. So here's a link to it. These slides will be made available to you, so feel free to sign up. And I believe that is it for, we have about a minute for questions. I threw a lot at you in a very short amount of time, so let me know. Next we have DeepRacer workshop, so which unfortunately or fortunately for you is me again. So, any questions? Anything you guys want to focus on or have interest in today? Yep. Yep.
This is also for medical specific?
Comprehend Medical is a medical specific iteration of Comprehend. So there's Comprehend, and then there's Comprehend Medical, which is designed for medical scenarios.
Like in any specific medical scenario?
I wouldn't say any specific, but like for instance, it's aware of things like dosages and is looking for things. It's aware of medical terminology. And one other thing about all of the higher level APIs that is worth noting, it's very easy to go into the console and just throw a piece of data in and analyze it. So if you want to kind of get a feel for how it works, the design is really done to be API driven, but each of the higher level services has a really decent UI that you can throw a piece of text in and then see what the results would be in a human readable and in the JSON form as well. So,
Just one more
yep.
clarification. Maybe we'll have discussion in detail. So for the autopilot, do we have any non-linear classifier or linear classifier?
I have to check. I don't know if Autopilot, let me get back to you on the break on if, and the question was, does Autopilot handle nonlinear classifiers? And Chris, maybe if you could take a look while we're doing it. I'll work to get an answer as soon as possible. I know it's currently, there's about 4, I need to look at the different models it will train on your behalf.
Two questions. The first one is on the transcribe. Does it render into like map all the way to like the coding level, like ICD or like standard format of the medical record?
The transcribe comes back in a JSON format, and it,
Can you repeat the
yep.
question?
Oh yeah. So the question is, transcribe. What format does it come back in? Transcribe medical specifically is what you're asking about, correct? Or
Standard format.
yeah, transcribe. It comes back in a JSON format, and I don't know if transcribe medical has this, but there is a real-time component as well to transcribe, which allows you to transcribe in real time and get results back in real time as you're talking. We'll show that later today.
And the second question is on the recognition. Does it estimate on
Does it
Estimate the quantity on the recognition.
estimate the quantity
Not
of,
just labeling the object.
estimate the quantity? Could you do, the
Like
question,
for
yeah.
example, example, right? There are 4 corn there.
Yeah, okay. You would actually calculate that based on the object detection of 4 corn, because you would get potentially bounding boxes for some of the labels. So you'd be able to say there's 4 different areas in the picture where, and the question is, does it estimate the quantity? The answer is it could, depending, especially if we're giving you bounding boxes. Not all of the labels that Rekognition provides give bounding boxes, and bounding boxes are the XY coordinates. But if there are bounding boxes, you could tell how many of each item there are, for instance. You could also move to SageMaker, which would allow you to build specific models to do things like counting. I know crowd counting is a very common use case that people use. With that, we need to transition over to the DeepRacer workshop. I will be here throughout the DeepRacer workshop and also throughout the day to answer any questions. And we have Chris and other presenters as well. So thank you, guys. And I believe we're going straight into the DeepRacer workshop. So now we get hands-on, which is nice. All right. So this is going to lead us right into lunch, I believe. Has anyone here played with DeepRacer? Is anyone familiar with DeepRacer here? Let me get to the beginning of this. All right. All right, so today we're going to go over the origin of DeepRacer. We're going to cover reinforcement learning for the Sunday driver, but really we're going to cover reinforcement learning. For me, the most interesting thing about DeepRacer is the experience you'll get with reinforcement learning. We're going to cover the virtual simulator, and we're going to get under the hood of the car, talk about the differences between the simulator and the real world, and then get you guys actually building and training a RL car in a virtual environment. And credits were passed out to everyone, which will be used in your accounts to help you build and train the models today. So, as we talked about in the opening, our goal is to put reinforcement learning in the hands of developers. This is the most literal take on that, which is how do we literally put reinforcement learning in the hands of developers. We started this back in 2017 with the Deep Lens, which was a computer vision, or is a computer vision camera that is built to host local inference of computer vision models. It's great for testing, training, and deploying computer vision models out into the real world, out into the wild, down on devices. Gets you experience with things like Greengrass, which is our Lambda at the edge environment. So how can we put reinforcement learning in the hands of developers? That is the DeepRacer, and then at reInvent, we actually added the concept of multi-car races and object avoidance with the DeepRacer Evo. The DeepRacer, as it stands right now, is available on Amazon.com, and very soon the DeepRacer Evo will be available on Amazon. The other thing I would note is there is going to be a pack that converts the normal DeepRacer to the DeepRacer Evo. The difference between these two is the addition of a second camera, which helps with distances. So when doing object avoidance, DeepRacer, as it originally stood, was a single car that you time trialed around a track. And if you haven't been, we run DeepRacers at all of our summits. So at the Javits Center in usually July or August, we have a summit where we host, amongst many other things, a DeepRacer race. The other addition to the DeepRacer Evo is the addition of LiDAR on the top. And the LiDAR gets you the back half of your car, so you can detect when a car is coming up for passing. So that was a new launch at reInvent. The DeepRacer Evo, we'll talk about these different components, the simulator, which we will actually start using hopefully in the next 40 minutes, and the DeepRacer League, which is a global league. There's a show on YouTube, and you can win prizes in the online and in-person league. You can win tickets to reInvent, you can win DeepRacer cars, credits, whatnot. We also added the ability for community race, so you could actually spin up a company internal race where you're vying for the best reinforcement learning model. So we'll talk about that today. So reinforcement learning. Is anyone here familiar with reinforcement learning as a concept? All right, so you may have seen 80,000 different versions of this AI ML embedded. I've seen humorous ones where it varies based on where things are. But the main thing to note is within the field of machine learning, there are multiple different approaches to machine learning. There's supervised learning, there's unsupervised learning, and what we'll be focusing on today is reinforcement learning. So supervised learning is example-driven, where all of your data is based on trained data. So the image classification, if you're building an image classification model or text classification, you need data and you need labeled data. We talked about SageMaker Ground Truth, which helps with labeling that data. For instance, if you're trying to find all of the corn in an image and you're not using a pre-trained service like recognition, you would need to feed a model in SageMaker, an object detection model, tens to hundreds to thousands of images of corn. And if you want to find the bounding box, you also need to know where in that image that corn is to train the model. So that is an example of supervised machine learning. Unsupervised machine learning is where you have no labels for your training data. So a use case here will be clustering. So if you're actually saying, take a set of data and just cluster all the like items, you're not labeling the data. You're saying just based on the data I'm giving you, cluster the like things. So k-means is a good example of a clustering algorithm. Now, the focus of this session is reinforcement learning, which is learning through the consequences of actions in a specific environment. So reinforcement learning, again, in the real world, reward positive behavior. So when a dog does something good, you give it a treat. Not punishing, by the way, we're not punishing, we are just not rewarding negative behavior. The goal is you end up with a well-trained animal. I don't know why he's wearing a lion. So to go through the terms that we'll be talking about today is you have an agent, which is your virtual car. You have an environment, which is the world that it operates in. And you have the state. And in DeepRacer terms, the state is what it sees through that one or two cameras. So for the DeepRacer, as it stands on Amazon today, you have a single camera, which provides an image, I think 160 by 220, and it does that 15 times a second. And every time you get an image in, that is a new state. That goes for both your virtual environment and in the real world. Based on that state, you will choose an action. That action could be go faster, could be go slower, could be go soft left, soft right, hard right, and decide. In the virtual world, based on that action, you will get a reward. And that's the whole concept of rewarding positive behavior. So we'll be doing this in a second, but you give it a reward. It's mathematical, it's a computed reward based on the environment you're in. And the goal of your model is to get the most points. It's to maximize the reward. And an episode is a full run-through of said environment. And in DeepRacer, that run-through could be a full run around the track, or it could be till you hit a termination scenario, which would be running off of the track. So in the DeepRacer virtual environment, when you're on the track, you are capable of getting rewards or points. As soon as you exit the track, your episode is over. So if your goal is to maximize the amount of rewards in a given episode, staying on the track as long as possible is the first and foremost thing you'd want to do. So we'll go into that. So the reward function incentivizes particular behaviors, and it's the core of an RL model. What we'll be working on today is those reward functions. That's the reality of what people are doing in DeepRacer. There's some hyperparameters and there's other things to talk about, but the most interesting thing is they are writing a reward function that is designed to beat every other reward function. And I will pull up a video of the fastest time. The fastest time around the 2019 track, the track that we ran at all the summits, is I believe 7.4 seconds. And it is a very large track. It would take a good amount of this room. It is 26 feet by 17 feet. So to have a small car go around that in such a short time is pretty impressive. I will pull a video up. Let's go into the reward function and how it works. So this is a simplified version of the car on the track. If you were trying to, and this is a reward that incentivizes centerline driving. So theoretically, this conceivably would give you the most points. However, which is the best way to go through this? If your goal is maximizing points, what's the best way to go through this? One would think. But if you want the most points, you would Pac-Man this thing. So this gets you the most points, but it's not the goal you're looking for. So you can add in a penalty function which says every time you move, you lose some points. So every time you take a step, maybe you lose 1 point. So that means doing this is not beneficial anymore. You now want to just go straight. So a lot of what we're doing is trying to figure out the right incentive for that. So it also will learn over time. So for instance, here is what you see, and we will actually get into the training environment in a couple of minutes. But what you see here is learning. It did the math. I got 2.4 points. And it's not as clear-cut as just the points, but you'll see a CloudWatch chart of your performance, and you can actually get an idea if your model is working towards convergence. So convergence is when you've hit the optimal learning path. You've learned everything there is to learn about the environment. Here, it's actually very easy. But if you think about the size of a DeepRacer track, which is again 17 by 26 feet, you're pulling in 15 frames a second. Every time you get a frame in, you can make an action on it. That's a lot of different actions. So learning what the best path is could take a long time. And that's what we'll be doing in the workshop, is building a model that runs in a simulation environment. So let me go back. Let's do this again. So what you'll see here it is, it's learning. Each time it's calculating the rewards in the simulation environment, and you'll see it gets better and better. It'll, over time, eventually get to hopefully a converged model. In the workshop today, I highly doubt anyone's going to get to a full converged model. But the other concept to know about reinforcement learning is the concept of exploration versus exploitation. So exploration is choosing a path that may or may not be optimal to gather information about it. So when you train in an environment, you'll see it actually will go through iterations of exploration and then exploitation. So this is unfortunately what you'll see for the first several minutes of your session, is a very frustrating view of a autonomous car just driving off the road a lot. But each time it does that, it gains information, which it then uses to retrain a model and deploy that model. So the simulation environment, and we'll talk about it in a sec, is a constant cycle of exploring, gathering that data, training a model, deploying that model, and then evaluating how it works. It's worth noting that once you deploy this model onto a physical car, which hopefully you guys will come to the summit and get that experience, then it is actually just exploiting. It's just using the information it learned in the simulation environment to try to get around the track. And that also goes for when you submit this race in the virtual leagues. One of the reasons we have you running in your accounts is so you can use the credits we give you today to train a model and hopefully enter the virtual leagues, maybe win some prizes, and whatnot. So exploitation, hopefully you get to something like this, which is your model has learned everything it's going to learn, and it now goes around the track in a very fast manner. This is the 2020 track, by the way, which is what we'll be running at all of the summits this year. It is available online, so you can, before you go to the summit, you can hopefully get a good model up and running and ready to go for when the summit happens. We also run them at conferences like reMARS and different, and reInvent. So, any questions? I know I'm throwing a lot at you here. Make sense to everyone? We'll see. So, recap before we get going. Reinforcement learning is this capability. I also want to focus on the different areas of reinforcement learning. I assume everyone in this room is not out there building autonomous cars. This is viable well beyond the concept of DeepRacer. There are, I think, 15 plus notebooks in SageMaker for reinforcement learning, specifically one that I like a lot, which is the contextual bandits, which is good for, is anyone familiar with the concept of multi-arm bandits when it comes to recommendation engines? So you can actually build a recommendation engine in a service that is learning based on click-through rates whether or not it is a good recommendation or not. So you've got a agent which is running in your application that's communicating whether or not the recommendation was good. If you show someone a recommendation and they click on it, that's good. If you show someone a recommendation and they don't click on it, that's probably not a good recommendation. So think of that as the reward function in this space. So we'll get to that in a sec. So the car in the virtual world, there's actually a lot of information provided to it because it's a simulation. And that is calculating that information. Distance from the center, are you on the track, are you off the track, that type of thing. In the simulation environment, it knows about the reward after each episode. So we'll go through here. Or actually after each state, it's state, action, reward, state is the kind of like the cycle. So what you have here is you have the agent, which has a state. That state is the frame you see right then and there. It will then choose an action. And in the simulation, you can then calculate the reward. That reward could be, how far am I from the center line? Am I zigzagging? Like you'll see, it's a Python function that allows you to really create the reward function specific to what you're trying to do. For anyone who's new to Python, we actually have several pre-built functions already in there. Avoid the, follow the center line. There's avoid zigzag. There's a couple of them. We've seen people build a function that's the most simple function of all, which is go fast and stay on the track. That's one, depending. So, but that's actually how it calculates, and that's exactly what we're doing in the workshop. Is that. So the combination of those is how you build and train your model. So let's go through the different algorithms. And right here, I'm talking about a vanilla policy gradient, which is it gathers episode information using the current policy. So that is the current neural network weights and information. And then you want to get the best path. So here we have climbing a mountain. So you're looking for the best cumulative reward to get up the mountain, for instance. Then what we do is we update the weights each cycle of training. This is not the policy optimization we use in DeepRacer. This is just a very vanilla example of policy gradient. In DeepRacer, we use PPO, or proximal policy optimization, for discovering the best policy. I want to cover, because I don't know if anyone was at the summits or reInvent 3 years ago. We actually had a hackathon thing called Robocar Rally. What we did is we took a RC car. This was kind of the genesis of what became DeepRacer, and we hacked that RC car to do autonomous driving. However, the way we did that was actually using a different capability called behavioral cloning. So reinforcement learning is what we've been talking about here, which is a virtual agent in an environment simulating thousands of times over and over again. And the result is provide a state and get an action. However, a way you could actually do this is also known as behavioral cloning. So the way Robocar Rally worked, and another way of doing this, is actually taking an RC car, driving around the track yourself, and recording the video of the driving with all of the steering information. So that allows you to control a remote control car, a real world car that has a camera, save those images and inputs, driving actions, and train a model. This is a supervised model, right? This is a supervised training model. You're providing it training data that's been labeled. Left turn, right turn, go faster, go slower. These are very different and have different goals and different capabilities. So one problem here is what's a problem here that you see? Track changes is one. The other one is at your very best, you're going to be only as good as that driver ever was. And that's where reinforcement learning comes in. Reinforcement learning can do better than that driver if given enough time and enough rules. And it can generalize across multiple tracks as well. We'll talk about the generalization of the model as well. So yeah, this takes longer, but creates a more viable, more functional model in this use case. I definitely don't want to position reinforcement learning against supervised learning. Different results, different needs. All right, so let's go into the neural network. And this is also an area we changed at reInvent. You can actually now choose the depth of your neural network in DeepRacer. The first layer is an input. You get your image, and then you actually have a CNN-based feature extractor, so a convolutional neural network that takes that image and extracts the relevant features. And by relevant features, I mean corners of the track, the off track, the on track, the center of the track. This is it understanding what's there. So once it extracts the features, it passes it to the policy network, which is actually then what decides the action to take. We've seen people get into the SageMaker notebook. So what we'll be doing today is actually all in the console. But as you will see SageMaker notebooks training. You will see RoboMaker. You'll see, and I'll talk about the architecture in a second. You'll see all the different components. But you could actually use the SageMaker notebook to really get under the hood of DeepRacer. And a lot of the people who are competing in the summits are doing just that. They're training on GPU, on SageMaker. So as I said, in Evo, you've actually got two images with an additional component, which is the LiDAR information, specifically the 90 degrees behind the car, measuring out to 0.5 meters. So, all right, let's get into the virtual simulator. I want to get you guys building as soon as possible. So here is the architecture of DeepRacer. As I said, you'll be able to go into each of these and see the work that it's doing. The DeepRacer console is really just a front end to put these services together in the effort of training a DeepRacer model. So what it is, it actually, S3 is where your model is stored. SageMaker is running a reinforcement learning training job. And that reinforcement learning training job is actually speaking to RoboMaker, which is running your simulation environment. You'll be able to go into RoboMaker and see the simulation environment. And if anyone's not familiar with RoboMaker, that is a service we launched 2 reInvents ago for building, deploying, and training, or building and deploying robotics. Here it is our simulation environment, which again, reinforcement learning is heavily used in the area of robotics. So you've got it creating a simulated environment which does gravity, the track, and you'll be able to see it. One area of caution, anyone who opens RoboMaker, you can look around at your simulation environment. Don't click too hard in there because you actually are changing the world that the car is training in. I've seen people pick the car up and put it somewhere else in the training environment. If you want to just see what's going on, Kinesis Video Streams has a live feed of the training environment. So RoboMaker is sending the video to Kinesis video streams. This is what you see. And again, CloudWatch is where all of the results, the metrics, your reward function stats are going. Also, OpenVINO we'll talk about later, but that's actually what's running on the physical car. So, the reward function, we talked about it. We're going to get hands-on with it. It's Python 3. We do have examples here. You can validate the code to make sure it works. I will be getting hands-on with the reward function in the lab. There are several, I think there's actually more than 3 because we added one for multi-car racing, and a validator. So again, it is Lambda. You write the function, and if you look here, we do have kind of examples of what's going on. Center line, if higher or closer, so you can see the rewards. This is the work we'll be doing today, and we'll walk around and help. So the track components, these are all very self-explanatory, but you have the wall, you have the field, aka not on the track, you have the boundaries, and you have the center. For DeepRacer, as long as at least one of the wheels is within the white, it is on the track. As soon as all 4 wheels leave the boundary, it is off the track, the episode is ended, and in a real-world race, your car would be reset because it is no longer on the track. When we talked about how the car knows, this is the information that it's used to calculate the reward functions. So in the simulation environment, you have waypoints. These are XY coordinates that exist to tell you where your car is in relation to the track. These are only in the simulation environment. They do not exist in the real world. But if your reward function is to stay close to the center line, this is the information that you'd use. You can also write your reward function to these waypoints. So maybe always point at the second waypoint out. You can use these, and these waypoints are inner track, outer track, and center track. So you can actually say, maybe hug the left. If you look at this track specifically, which is the 2019 track, notice how it's mostly all left turns if you're going that way. Maybe the inside of the track is the better way to go. If it's all right turns, maybe the outside of the track is the way to go. That is the, or facing the other way, depending. So you can write your reward function based on these type of information. There's actually a lot of different parameters. One thing that's very nice is if you go in the console, there's a lot of guidance, a lot of instruction. There's actually videos inside of the console for each of these parameters and what they mean. So heading is an example of a parameter that you could code towards. All wheels on track. Again, this is the most simple reward function is every wheel on the track. So every time that happens, it would get a penalty. So that would help you stay on the track, but I don't know if it would necessarily help you with your zigzag problem. So that's where distance from center may come in. So maybe you want to stay only on the left side of center, only on the center. There is a lot of different parameters that allow you to help you with this. One of the enhancements from reInvent is you can actually customize your car. Because we now have multiple different options with the DeepRacer Evo, you can build a vehicle which will have things like what components, single camera, multi-camera, LiDAR. So you'll be able to customize the sensors most likely to correspond with what race you're trying to win. If you're trying to win a standard DeepRacer race using a standard DeepRacer car, you would not want to create a virtual car that has LiDAR and the stereo sensors. And the stereo sensors are designed to give, again, distance from an object. So one of the capabilities in DeepRacer Evo is you can put boxes on the track, and the car should avoid them. So similar thinking down the line of any autonomous vehicle, object avoidance is pretty key. This would be the way to tell when to turn around that object. If you think about a single camera, you don't have depth. So the action space. This is actually very important when it comes to how you're training your model. So the action space is what action you can choose when you're doing the training. You can actually choose the maximum angle, so that can be 30, 15. If you don't want to turn that much, again, depends on your track. The default is 30. Many people leave that one default. The steering granularity and maximum speed, these are important. Steering granularity you can actually set at 3, 5, or 7, and that is how many turning angles do you want? Do you want one turning angle, just left, or soft left, hard left, that type of thing? The importance there is the larger your action space is, the longer your model will take to converge. There's a lot more options. The explore exploit cycle, you now have, and you'll see the math down here, the number of actions. The math of what you can do if you have 7 steering angles. You can also set your maximum speed. This is actually higher than 4 now, by the way, up to say 10, I think. And then you can set the granularity. The granularity is how many steps in your speed. Do you want to go 1 speed? You could say I want 1 speed. I can go 10 meters a second and I have no capability of slowing down. That is okay, but if the track has turns, you may not be able to make said turn. So that's where you can actually set your speed granularity. But that's another action. So if you actually have 7 steering granularity and 3 speed granularities, that's 21 different actions that you can make in a given state change. You can experiment with different ones. Today, when we're building, you'll be able to actually train 3 models at the same time. So you could train one and then try a different one, train a different model while your one is training. You'll be able to see the CloudWatch logs the whole time, so you know whether or not your model is trending positively. The first 5-10 minutes, give it time. None of them are going to have a good reward score, but then it will get there. So under the hood. So the car, as I said, we'll talk about the actual car. It is a 1/18th scale RC car running Intel Atom. It's running, it actually has Ubuntu running on it. You could check your email on the car if you wanted to. And then it also has the Intel distribution of the OpenVINO toolkit, which is what does the inference. It has 2 cameras in the Evo, 1 camera in the standard, same camera, just 2 of them. And it has a 360-degree LiDAR sensor. It has 4 gigs of RAM. It is running ROS, or the Robotic Operating System Kinetic, currently. And here's what it looks like. So you have the sensor, which actually processes the media, goes into a video processing, which then does 2 things. The web server just comes back to your tablet so you can see at all times what your car sees. You can turn this off if the Wi-Fi is not great when you're racing. You can turn the web server off for the video, that is. This is the important one, which is the OpenVINO, which is running an inference. It's doing that processing that we showed you in the neural network. It is then processing it, passing it to a navigation node, which is choosing the action, which is actually turning the wheels of the car or making it go faster. There's also a manual drive capability. That's really just to show you how to drive. You actually can't do behavioral cloning with it. You could just drive it, but it is a web server-based drive car. It allows you to steer it, turn it. You could go around the track yourself if you wanted. And that all controls the car. So again, the input data is optimized with OpenVINO, which gets the inference results. Again, this is all part of the Intel package, including Atom. You do have the toolkit here if you want to get playing with OpenVINO. All right. We have a lot of resources here. The DeepRacer community is huge. Check out DeepRacer TV on YouTube. Again, at first you'll get fairly slow results, but as you work with it more, you'll get better results. Currently, the world record is 7.5 seconds. My goal today is to hopefully get some people in the 10 to 20 second range, which is a good perspective. Honestly, completing the track is a victory in such a short workshop. Getting around the track 100%, You'll see the results. We'll show you how to go through that. And I'll probably start a training going while we do the lab as well. So let's get started. So in your accounts, here is the content for the workshop today. I'm going to leave this up here, and then in a little bit, I'll actually start building it. Raise your hands. We can come around with help if you have any issues. Also, if you have any questions, let me know. I can take them as I go. pull down here. And for anyone that doesn't have an account, if you create an account, the $70 that credit was given, I believe we're using a different service for the other workshops, so you can actually use all of it on the DeepRacer if you want. But you can create an account on the fly and have the credits work as well. So pull down. Sure, how quick? That should happen pretty quickly. So to apply the credits, it's in the My Account under Support. There's a credits section under, if you pull down, I think under your name, let me see. So if you pull down under the account name, under My Account, there is a section for credits, and yeah, under billing. So, and then also DeepRacer is in North Virginia, so you do have to be running out of North Virginia. Any other region, I think you'll get an error on it. Just a reminder that you can train up to 3 models at the same time. So if you get your first training, you can try one with a different set of settings, work different, see what works. So, and if you don't like one that's running, you can stop it and then train another one. So once you get your first one training, use that information and build other ones as well. And yeah, for anyone who wants to do this after the fact, these are not going anywhere. These are in your account. The credits are good. You can run this whenever you want. The GitHub code is available. It's public. So yeah, you could easily stop back and retrain a model whenever you want. But yeah,
Just basically take the parameter name and you put it in there.
yeah.
Params, blah, and it's set to your nerd.
There's more. I gotta find. There's another section where it had each code sample had some code with it, but I have to see if the documentation's changed. Oh, like right here. Here it is. So right here, each one of these has code with that. So if you go to each of these, you'll get code for each of these reward function examples. So object distance, for instance, if you want a code sample there. Yeah, and then on the right this is the most important part, which gets you each one of those, because what you saw was just a kind of overall summary. Let me see if I can get one going. So if you look right here, you get your training environment. You get some of this, but right here, you can get down into these logs, which get very detailed. It might be more information than you're looking for, but as far as the right here, yeah, this is the, not each iteration, but the log will have, it's each training job. So if you go into each training job, there's going to be a lot of SageMaker logs that are here. View logs. And this is where it gets very, this gets you more information about rewards, episode, total reward steps, and a step is how long each state action reward, state action cycle happened. Okay. So this was 651 steps, total reward is that. So this gets you more information, and then there's other logs that get even deeper. Okay. Hold on.
Cool. Yeah, just trying to see like this cycle of action, state action.
Yep.
And see what it actually did.
So let me see if I can find the.
Please welcome your host, sportscaster and reporter for the AWS DeepRacer League, Ryan Marine.
On the clock.
So here is the final at reInvent to give you an idea of what the car looks like going around the track.
There you see it, 1 minute and 30 seconds on the clock. The car placed at the start-finish line. Sola has the tablet at hand. She'll have the control of the throttle there. All right, let's get our countdown to the green flag on. Here we go. 3, 2, 1. Sola, your 90 seconds has begun. So this is a different track layout here this year than we saw throughout the circuit this year. Also, it's a different layout than we saw at reInvent a year ago.
So the way it works is you get, in the finals, you got 90 seconds, but at a summit, you get 4 minutes. And in 4 minutes, you need to complete the track. So if you saw the car went off the track, so this lap does not count. But she has 90 seconds to try. And she is the world record holder of 7.
It's much different here. That lap will not count.
Yeah.
The car went 4 wheels over the white line. That's what our track boss is watching, as you saw right there. Now, this is costly for Sola because there's only 90 seconds to work with. Remember, we talked about her style. It's very aggressive. She tends to come out of the gate very fast and slowly dial back the intensity to find that hot spot. Here we go. That's the first official lap of the summit so far. 12.384 seconds. Looks like this lap will most likely not count. Coming around here, starting the next one. Still has that 12.384 to fall back on with just 30.
The other thing to note is you'll notice she has a tablet in her hand. When you do a race in the real world, you actually can control the speed of the car. That's not a gas pedal, which is what people frequently think it is. It's actually designed to tune the RC car, which has a battery that drains over time, to your training environment. So you're designing the speed to be as fast. So a car that's just got a fresh battery is going to go slightly faster than a car that's been running for 10 minutes. So you're designing the speed to match your training environment. If you try to go faster than your training environment, those state inputs are going to come faster than your camera is ready. So the actions, if you watch on the car, if it turns too early, you're probably going too fast. If it turns too late, you're going too slow. So she is spending that 90 seconds adjusting the speed, which is the only setting you can adjust for the autonomous car. And that's the kind of real world versus simulation. Simulation, you're always going the right speed.
Seconds remaining.
Yeah.
It's worth noting that just 90 seconds to work with. I think our developers are likely to be a bit more conservative, but how about that? Not much conservative about a 10.236. Just 20 seconds remaining for Sola. Can she improve? We're looking at best, perhaps 2 laps. And it's critical to get a nice running start, if at all possible. But it looks like she's going to have to do it from a standing start. This will be the final lap. Matt, get that checkered flag ready. The clock has hit 0. She'll be allowed to complete this lap. Can she improve on 10.236?
So in the 90 seconds, she went 10. When she had 4 minutes, she got down to 7.5 seconds, but it wasn't the championship. But at the same time, this track is actually about 30 feet by 20 feet. So let's see. The other thing to note, if you want an idea of how your environment is doing, you can turn this setting on, which allows you to actually see the percentage of your track. So if you look right here, this is a model I've worked on for quite a while. Early on in the training, it didn't do very well. And then as you see here, I haven't converged clearly, but I've gotten close. This one goes around the track in about 10 seconds. It's definitely not world record holding, but for me in my spare time, it is decent. Has anyone got one that's running and completing a track? Who's got their models training at least? All right. A couple things to show you while you're doing your training is you can actually go into each of these services. Here, I'll clone this one and get it going. Also, when you clone a model, this is for when you're trying to compete in the virtual race, it preserves all the neural network weights. So you should be able to improve your track. You can change the reward function once you clone a model. Let's see. I'm going to try a time trial. Time trial is the standard one. This is my reward function, which I believe I used I think I did a simple one and just trained the heck out of it is what I did here. And then the other thing is the evaluation. So as I said, the training is the explore exploit cycle. Evaluation is the same as if you were doing this in a real world race. It no longer is learning, it's just using what it learned to run through the track. And if you see, we have the community races where you can create a race that can be done inside of an organization. You can invite people to the race. The date. So what we do for the virtual tracks, if you look here, we actually run the virtual league month after month. So me trying to do another one. So if you look, we have the 2019 DeepRacer Cup. These right here were done throughout our summits. So they lasted different months of the year, August, September, June, May. So we'll start this again with virtual leagues that you could enter, and each race is slightly different. And we had winners on each race. So you can actually look at the standings. And see who won each one. So each one of these comes with prizes that these different people won. And you can see the time and points that they got. So 9.7 seconds for the London Loop, for instance. All right, and we have about 40 more minutes, but again, these aren't going anywhere, so you can train throughout the day, train throughout the week, use the credits to hopefully enter into the virtual leagues. So we're using SageMaker. It trains on C4 instances. We're using RoboMaker. It averages out to a couple dollars an hour for training. So you could actually check your bill after the workshop today and get an idea how. It's going to vary. If you train for 400 minutes, it's going to be more expensive than you train for 60 minutes, obviously, because it's the main resource offenders that would be a concern are RoboMaker, the simulation environment, which actually let me show you the simulation environment as well, RoboMaker and SageMaker. But it is designed to be pretty cost effective, a couple dollars an hour for training and simulation. So the 70 should last. Generally, when we do this workshop, we give out $25. So 70 is definitely a decent amount. So if you look here, now that I have something up and running, if you look at DeepRacer, what you'll see here is I have my simulation environment running. Right now I haven't got any rewards yet, so I assume it's just starting up. This is Kinesis video streams right here. So you can actually, while you're training, you can go into each of the associated services and kind of see them running and doing what they're doing for you. So right here, I have a video stream up and running right here. So load that, and then I'll go over into RoboMaker as well. As I said, be careful in RoboMaker because you can mess up your environment. This would be if you wanted to change, like this has all of the, and it, for this one we're running Gazebo is the simulation tool that we use. So if you look right here, we can top down it. Oops. Let's top down, yeah, there we go. So now you can see the simulation environment. If you want to see, but as I said, you can pick the car up, you can actually change the physics of the environment. If you want to train a Mars rover, for instance, this is where you set the physics, gravity, all of these things. This is all part of Gazebo, which is the RoboMaker built-in training environment. Change the lighting. If you notice here, this looks very similar to what you saw in the reInvent track. In order to back there, in order to train a model that works, you need to actually make the real world look as much like the simulation environment. We did launch some new features just before reInvent that allows you to do multiple different types of training. If you don't want to get a track, you could get white tape, yellow tape, and a gray floor and do that, or change the training environment, change the simulation environment to not use those colors. This is the domain to real world transfer problem that comes with reinforcement learning and simulators. So that's designed to look as much like the real track as possible. But if you get a real track and you put harsh lighting on it, and that lighting reflects off of a glossy surface, you might create white lines that didn't exist. If you're wearing white shoes on the track, that camera could see the white shoes and infer details. So that's where you want to create a real-world track that looks as much like the simulation, or generalize your model by training across a lot of different spaces. Something interesting you can do is you can actually train, it kicked off. I'll put it back on, see, but it kept flickering. I don't think so. Maybe? Oh, let's see, yeah. But it keeps flickering when I do it. So, but on top of that, what you could do is you could actually train it multiple times on multiple different tracks. What a lot of the successful people did is they actually, I can talk through it, it's fine. But they actually trained in a way that actually trained on the reInvent track, then maybe the London track, because you want a car that drives on whatever track it sees. You don't want to only train on one track, because then you might not have a model that works across the board. So if you look here, this is a pretty decent model. It's staying pretty true. It's not zigzagging a whole lot. I'd say it could go a little faster possibly, but this is a good example of a decent model. But it's still learning. So what you'll see is you'll see my score over time as it trains, hopefully get better. Let's go back to my DeepRacer. Oh, the last one I wanted to show you is SageMaker. So as we said, these are all the different services that are acting in conjunction. So I should have a training job running, which is my DeepRacer training job, which is running on a C4, I believe. Yeah, C4 2x large. So not even that expensive of an instance. You can get in, look at the logs. So here is the training logs as they're coming in. So you can see my steps, my rewards, the iteration, all of that data. Now let's go back into DeepRacer. And you can see my reward graph should be populated now. it's starting to populate. So 100%, 100%, 100%, 75 reach termination environment. So as this gets more, you'll start to see charts and information. So the goal here is to complete as much of the track as possible and likely have a reward chart that's trending upwards. That's how you know you've got a reasonably good model. This one is doing all right. So yeah, let me know if you have any questions. We're around, I think in 30 minutes is lunch, and then we're back with, I don't know what sessions after lunch, but I'll be around throughout the day. So. Yep. Yep. Yeah, absolutely. Yeah, you can use any of those parameters in any way that you want.
But only these parameters, right?
What else would you want to use?
Say, I would
Like you could create derivative information from these parameters that you use.
From these
Yeah,
parameters,
yeah,
right?
yeah.
Okay.
Like the parameters are just inputs. They're not like they're information you can use to calculate different functions. The score isn't as always important because I've seen someone create a reward function that just added a multiplier of 100. So their reward function scores were in the tens of thousands. That didn't make their model work any better. Yeah.
But we have to be actually four here, right? The maximum steering angle, then we have steering angles, then we have
Yep.
speed. So only these four spaces, action spaces we
Yes, that's the action space. Yeah.
we don't have anything additional.
For an action, well, because you can only go straight, left, right, or faster or slower. I mean, there's no. We've heard some talk of other potential things like maybe on a curve, but that's still not a decision. Like, there's no other things the car can do. The car can only go left, right, fast, and slow.
Yeah, but it can be impacted by the external environment, right?
Yes, and that is another thing to note is the car does not currently feedback metric data into the computer. We've heard an ask for that, and we do try to listen to all customer requests to where you're understanding the turning. Like right now, it's what you see is what you act on. What would be great is if the computer was getting metrics back in real time. Currently, it does not do that. So. Yeah.
Did we try this for like other?
there's no playback methodology for the video. So right now the video is done during the training, and the data's there, but there's not a good way to get back to it in Kinesis video streams. It's kind of not persistent. So.